Assalamu alaikum and welcome to Teach Maxim. Today we're doing an introduction to programming fundamentals using C++ in a Linux environment. So, first of all, basic introduction to C++. C++ is a high-level language. Uh, a high-level language meaning that it has syntax, uses words from English language, load, string, namespace, things like that, right? That's the basic concept behind a high-level language. Other than that, it is a strictly typed language, which means that you can't do weird shenanigans with it. You can type a string to an integer, a number to a word. So things like that. You can do you can add a word to a word sentence. Basically you can add numbers, but the numbers have to be of the same type. So that's strictly typed. Other than that, it is a compiled language. What do I mean by compiled language? Well, you need to compile your code first. So for instance, I had this code in test.cpp. So I need to compile it. And well, this is giving me an error because it's doing something. Alright, so here we are, it is compiled. We're going to run the executable, and well, it's going to be an output. I'll explain the output in a bit, but for now, you need to know that C++ is a compiled language. Uh, you should know that Python is an interpreted language, which basically means that it doesn't produce an executable. You don't need to compile it, it just uh, runs the code on runtime. You don't compile it beforehand, it just runs it. Let's try that. So I have a Python file with me, and this is it. You don't need to compile it, it just runs it. That's the difference between a compiled language and an interpreted language. Alright, so let's move to the code for a bit. This is the basic syntax of a C++ program. So first of all, you include some files, header files. These files include some sort of programming structures for the things you're going to use in your code. For instance, I'm using a string here, so I need to include this header file string.h, which gives me access to uh, the data type that I'm using. You don't have to do it for every data type. String is a unique one, let's say. Uh, Other than that, you use iostream to to put an output with your program. All right. Uh, these angular brackets that you see here, they tell the program to you know go to a specific place to search for iostream or string.h. Over here, it means that your program is gonna go to your root, then it's going to go to your SR user basically in the include folder, and it's going to search for the file that you included. So I just string.h, here's string.h, and in the same way, iStream is also here. So that's the main concept between the include using namespace std. Alright, so I'm telling the code that hey, I need to use cout, I need to use handle rather than separately referring to them. I'm going to call the namespace that has the reference. So if I don't want to use it, I can run the code, but I'll have to make some changes. So let's try to compile it. It's going to give me an error. Why? Because it doesn't know what cout and handle is. So let's go here again and change it a bit. Here I'm basically saying that this is the namespace where you find the cout and handle. Cout is used for output and handle is used to end the line. And other than that, I'm going to comment these things. Let's include this as well. Alright. String. Alright, so as you saw earlier in the code, I'm saying that std colon cout and then hello world. So I'm saying that cout is in the std namespace and these two symbols basically connect std and cout. Alright, other than that, what you need to know at the beginning is give me a moment. You include the header files at the top. You use the namespace if you want to, and between this place you can initialize a global integer. So these brackets that you see, these make a local code for your program. So I've made a function int main, which is basically your default function, and these brackets specify the scope of this function. So anything that's before this scope, you can use it later on again and again and again. It's basically a global identifier, a global variable that is not specific to any scope. But let's say you have this integer. This integer can only be used in the scope of this function, which is defined by these curly brackets. Alright, that covers that, and the semicolon basically breaks the line which you're working with. It separates the line of codes. So I did a initialization of a string here. To move to the next line, I need to use a semicolon. If I don't use it, it's going to throw an error. Why? It's basically going to continue reading the next line as part of this. It's going to mess it up. Alright. Other than that, what you need to know is there are two types of errors, a semantic error or a logical error. A logic error is an error which is basically dependent on how you're making your program. If you use the wrong logic to tackle a problem and uh, don't get your required output from the program, it's a logical error. Semantic error is an error in the, the code itself. This, you're breaking sort of a rule in C++. That's a semantic error. For instance, string, well, what the uh, string is a data type, but string is nothing. So it's going to throw an error right here. This is a semantic error. All right. So what do I need to do with this? Oh, oh yeah. Uh, how this code works is, first of all, uh, it's pre-processed. So in a pre-processing, uh, the preprocessor goes through your whole code file. It sees that you've included some header files. It includes them into one file. It makes one file and then it forwards it to the compiler. Now the compiler gives you assembly code. Then it goes to an assembler. Then it makes an object file. Then it goes to a linker, which produces the executable that you run. Uh, right now, this command runs the executable T that I made by using this command. So I'm using G++ as a compiler. It compiles test.cpp and it makes the T executable file. -o means that I'm going to rename the executable that test.cpp is going to produce into T. Oh, I believe I made an error. Alright, let's see. There's this. So here we go. This is the output it makes. Now if I don't use this -o flag, it's going to produce an a.out. And then I need to run the a.out and it produces the exact same result. So by default, it's going to produce an executable named a.out. But if you want to rename it to something yourself, you are going to use the -o flag, and then you're going to tell it the name that you want it to be. That's it for the intro, and the next video, let's do something else, maybe we'll set up the environment or something. Anyways, see you in the next video.